This article discusses the imaging of 3D objects. For an abstract mathematical discussion, see projection. Oblique projection is a simple type of technical drawing of graphical projection used for producing two-dimensional images of three-dimensional objects. The objects are not in perspective, so they do not correspond to any view of an object that can be obtained in practice, but the technique does yield somewhat convincing and useful images. Oblique projection is commonly used in technical drawing. The Cavalier projection was used by French military artists in the 18th century to depict fortifications. Oblique projection was used almost universally by Chinese artists from the 1st or 2nd centuries to the 18th century, especially when depicting rectilinear objects such as houses. Overview. Oblique projection is a type of parallel projection. It projects an image by intersecting parallel rays from the three-dimensional source object with the drawing surface. In both oblique projection and orthographic projection, parallel lines of the source object produce parallel lines in the projected image. The projectors in oblique projection intersect the projection plane at an oblique angle to produce the projected image, as opposed to the perpendicular angle used in orthographic projection. Mathematically, the parallel projection of the points on the plane gives the constants and uniquely specify a parallel projection. When the projection is said to be orthographic, or orthogonal. Otherwise, it is oblique. The constants and are not necessarily less than 1, and as a consequence lengths measured on an oblique projection may be either larger or shorter than they were in space. In a general oblique projection, spheres of the space are projected as ellipses on the drawing plane, and not as circles as you would expect them from an orthogonal projection. Oblique drawing is also the crudest 3D drawing method but the easiest to master. Oblique is not really a 3D system but a two-dimensional view of an object with force depth. One way to draw using an oblique view is to draw the side of the object you are looking at in 2 dimensions, that is flat, and then draw the other sides at an angle of 45 degrees, but instead of drawing the sides full size they are only drawn with half the depth, creating force depth adding an element of realism to the object. Even with this force depth, oblique drawings look very unconvincing to the eye. For this reason oblique is rarely used by professional designers and engineers. Oblique pictorial. In an oblique pictorial drawing, the angles displayed among the axis, as well as the foreshortening factors, are arbitrary. More precisely, any given set of 3 coplanar segments originating from the same point may be construed as forming some oblique perspective of 3 sides of a cube. This result is known as Polks Theorem, from the German mathematician Polk, who published it in the early 19th century. The resulting distortions make the technique unsuitable for formal, working drawings. Nevertheless, the distortions are partially overcome by aligning one plane of the image parallel to the plane of projection. Doing so creates a true shape image of the chosen plane. This specific category of oblique projections, whereby lengths along the directions and are preserved, but lengths along direction are drawn at angle using a reduction factor, is very much in use for industrial drawings. Cavalier projection is the name of such a projection, where the length along the axis remains unscaled. Cabinet projection, popular in furniture illustrations, is an example of such a technique, wherein the receding axis is scaled to half size. Cavalier projections. In Cavalier projection, a point of the object is represented by 3 coordinates, x, y and z. On the drawing, it is represented by only 2 coordinates, x and y. On the flat drawing, 2 axes, x and z on the figure, are perpendicular and the length on these axes are drawn with a 1:1 scale. It is thus similar to the dimetric projections, although it is not an orthographic projection, as the third axis, here y, is drawn in diagonal, making an arbitrary angle with the x-axis, usually 30 or 45 a degree. The length of the third axis is not scaled. It is very easy to draw, especially with pen and paper. It is thus often used when a figure must be drawn by hand, for example on a blackboard. The representation was initially used for military fortifications. In French, the Cavalier is an artificial hill behind the walls that allows to see the enemy above the walls. The Cavalier perspective was the way the things were seen from this high point. Some also explain the name by the fact that it was the way a rider could see a small object on the ground from his horseback. Cabinet projection. The term cabinet projection stems from its use in illustrations by the furniture industry. Like Cavalier perspective, one face of the projected object is parallel to the viewing plane, and the third axis is projected as going off in an angle. Unlike Cavalier projection, where the third axis keeps its length, with cabinet projection the length of the receding lines is cut in half. Mathematical formula equals, as formula, if the plane facing the viewer is, and the receding axis is, then a point is projected like this. Where is the mentioned angle? The transformation matrix is. Alternatively, you could remove 1/3 from the leading arm projected off the starting face, thus giving the same. Military projection. In the military projection, the angles of the x and z axes are at 45 degrees, meaning that the angle between the x-axis and the z-axis is 90 degrees. That is, the xz plane is not skewed. It is rotated over 45 degrees, though. Examples. Besides technical drawing and illustrations, video games also often use a form of oblique projection. Examples include SimCity, Ultima 7, Ultima Online, Earthbound, Paperboy and, more recently, Tibia. See also. References. Further reading, Foley, James. Computer Graphics. Boston, Addison Wesley. ISBN 0-201-84840-6. Ingrid Kuhlbaum, Joseph Pasiarek, Planar Geometric Projections and Viewing Transformations, ACM Computing Surveys, V10N4, pages 465-502, December 1978. External links, Illustrator Draftsman 3 and 2 Volume 2 Standard Practices and Theory, page 68 from http://www.tpub.com